Hello and welcome back to mathematics. My name is Joel, teacher of mathematics. I welcome you back to mathematics. Continue subscribing to my YouTube channel. Also follow me on Facebook. I'm also on TikTok and even on Instagram. Thank you and welcome back. Today we are looking at the conversion of recurring decimals to fraction. We will have three scenarios where we will tackle all of them. The first one, as you can see, it is that one. You also have the second scenario, and you also have the third scenario. So we are going to start with this one. Conversion of recurring decimals to fractions, you can find it on grade 8 in junior secondary, and it also on Form 1 and Form 2 if we are looking at the senior school content. So, welcome and see what shall happen. Now, look at this. If you are dealing with recurring decimals to fraction, I have the simplest way. I know that learners always have challenges, but now I have the simplest way. My simplest way, I tried to analyze and saw that we only have two ways or two steps. Step number one, we attempt to put the decimal point before the first recurring digit. And the second step, we put the decimal point after the last recurring digit. So in this case, we have the decimal before the first recurring digit, so we are not going to change anything. And the second step, we will attempt to put it after the last three. Now, if the original decimal moves, we will count the number of steps and that will represent the number of zeros. So now look at this scenario 1, which is 2.343. The first 3 is recurring. So now, because the decimal is already before the recurring digit, we are not going to multiply with anything. Now this one, we will just represent it as n. So we are going to have n as 2.343. Now I have said the second scenario is whereby, or the second step, now this decimal, we are not going to move it in the first step because it is already before the recurring digit. Now the second step is now we attempt to move this decimal place from here to the last recurring digit. So now you can count the number of digits you have passed through. So we have 1, 2, 3. 3 zeros represents 1,000. So you will say now this one is 1,000 n, which is equivalent to what? Now the decimal is already here, so we'll have 2343 point. We repeat the recurring part, which is 343. Now, this is 1 and this is 2. Now we subtract 2 from 1 and we shall have the 1,000 n is equals to 22,343.343. And the first one, which was n, equals to 2.343. We subtract the 2. We subtract the 2 now. This one is 1,000 minus n. You remain with 999 n is equals to this minus this one is 0, this minus this is 0, 3 minus 3 is 0, then 3 minus 2, get 1, then this 4, then this 3, and then 2. So now we have 999 n is equals to 2341. We need to remain with n here. So you divide by 999, divide by 999. So n will be our fraction now, whereby you can define this one to this one to get the mixed fraction. If you have a calculator, you can just put 2341. There's a button written A, then B over C. That one, you just click it, then put 999, and you are going to get the mixed fraction as 2 and 343 over 999. So this is the easiest way that I invented for putting the decimal point just before the recurring and after the recurring digit. So that is scenario 1. Now I have scenario 2, which looks like that. So now, if you keenly look at this question, the decimal point is not before the recurring digit. So this is the original decimal. We said we only have 2 steps, putting the decimal point before the first recurring digit and after the last recurring digit. So our decimal in this case is here. So we need to put it at this point. So now you've jumped only 1 digit. So 1 means 10, which is 10. So we'll have 10n is equals to, now the decimal is here, so we'll have 2.45. Just like that. You just repeat this, the recurring digits. Now, that is step 1. Step number 2, we move this original decimal point to the last recurring digit, which is 5. So how many steps do you move? 1, 2, 3. So those are 3 zeros, and 3 zeros means it is 1000 now, n, which is simply 245.45. Now, this is 1 and this is 2. Now you subtract 2 from 1. So it is, we'll have 1000 n is equals to 245.45. And the second one is 10n is equals to 2.45. And now you subtract the 2. You don't need to follow the other steps, which seems to be too long for the student and they get confused on the way. So 5 minus 5 is 0. 4 minus 4 is 0. 5 minus 2 is 3. Then this is 4 and this is 2. Is equals to 1000 n minus 10 n, you get 990 n. 990 n. So now we need to remain with n on this side, so you can rewrite the question 990 n is equals to 243. So divide by 990, divide by 990. So in simplest form, you can simply solve this one to the simplest form. And in the simplest form, you are going to get 27 over 110. So this one, you just simply divide it by 9. If you divide this by 9, get 110 by 9, get 27. And this is now the second solution. of this recurring decimal. Uh, we have another scenario with me here, which looks like that. We have after the decimal point, we have two recurring digits which follow each other. And now, remember we said that we put the decimal point just before the recurring digit and after the recurring digit. And if it is just before, that number will be just represented by n. So in our case, this is n, which is equals to 1.67. We have just written it like this because the decimal point is just before the first recurring decimal. Then now we want to put the second step, we want to put it here. So from here to here, we will have jumped how many digits? 1, 2. So those are two zeros and two zeros means 100, n. So 100n will be the same as 167.67. So remember, we have already multiplied this original number with 100. So if you multiply this with 100, you will have 167. Then you write the, because it is recurring, you will have 0.67. Now you subtract this one from this one. So we'll have 100n is equals to 167.67. You subtract it from n, which is 1.67. Subtract this one, you get 99n is equals this minus this is 0, this minus this is 0. 7 minus 1, you have 6, and you have 6 and a 1. So we want to remain with the n here. So you defined by the coefficient of n, which is 99. And you defined this other one by 99. Then we'll have n plus. You calculate this one in improper fraction, the improper fraction into a mixed fraction, whereby if you calculate that one, remember I said if you have a calculator, you can just key in 1.66, no, sorry, 166. Then there's a button up there on your calculator written ABC. You click it, then now you key in 99, and then now you click the equal sign, you will get 1 and now 67 over 99. So thank you very much for listening and following my YouTube channel and following my lessons. I wish to welcome you once again to support me, to subscribe to my YouTube channel, to refer me to any learner who needs assistance in mathematics, and I will really appreciate. My handles are on TikTok, Dr. Joel Musivi, Facebook, I'm also on Dr. Joel Musivi, on YouTube, also Dr. Joel Musivi, Instagram, Dr. Joel Musivi. All those handles I'm doing this mathematics to try and help the learners. Remember to watch my previous videos on the simultaneous questions through substitution method and elimination method. In the next lesson, I'll be doing simultaneous question using graphical method. Thank you.